Hello everyone, my name is Parth Chadda and this is my task submission video for 7.1p of SIT232. In this video, I will explain how inheritance and polymorphism are used in banking system, how one method can perform all types of transaction, what changes are needed to add a new transaction, and finally, the advantages of both the concepts. First, let us start from how inheritance is being used in my solution. In my program, I have created an abstract class called transaction here. Uh, this class contains all the common properties like amount, success status, execution state, reversal state, timestamps, and it also defines the common methods like execute, rollback, and print. I have created child classes as deposit transaction, withdraw transaction, and then transfer transaction. These classes inherit from the transaction class. This means they reuses the common code from the parent and only implement their own specific behaviors. Uh, for example, deposit transaction can handle the deposit logic here, and withdraw transaction will handles the withdraw logic, while transaction transfer transaction combines both the withdraw and deposit logics. So instead of rewriting the same logic again and again, inheritance helps us to reuse the code and maintain a clean and clear structure of our code. Now let's talk about polymorphism. Polymorphism is used in bank class, specifically uh, in this method called execute transaction here, which I have created. Here, the parameter of the type transaction, which is the base class, but at runtime it can accept the deposit transaction, withdraw transaction, or transfer transaction. So even though the method is the same, but the actual behavior changes depending upon the object passed. This is called the runtime polymorphism or the method overriding. Next, looking at how one method can perform any kind of transaction. This is possible because of polymorphism. We call the bank execute dot transaction tx. The program is automatically calling the tx dot execution, the transaction tx. Now, depending upon the object type, if it is a deposit transaction, deposit logic will run. If it is a withdraw transaction, then withdraw logic will run. If it is a transfer transaction, the both operations will run. So, in a single method works for all of the transaction types, making the system flexible and scalable. Now, what changes are need to add a new transaction type? Let's say we want to add a new transaction like interest transaction. We only need to create a new class that inherits from the transaction, override the execute method. We can also override the rollback or print if we need it. That's it. We don't need here to modify the whole bank class code at all because it is already working with the base transaction type. This shows that the system flows are based on the open close principle, open for execution, closed for modifications. Now let's discuss the major advantages of inheritance. It reduces the code duplication by sharing the common logic. It improves code reusability. It creates a clear hierarchy and structure. It makes the code easier to maintain and extend at a good extent. Some validations like execution checks can be handled in one place rather than writing them multiple times. Finally, the advantages of polymorphism. It allows one interface to handle multiple behaviors, make the system flexible and scalable, reduces the one if else or switch case complexity, improves the readability and maintainability of the code. It makes it easy and add new features without changing the existing code. In conclusion, I would say that in this system, inheritance helps us to reuse the organized code, while polymorphisms allows us to execute different transaction behaviors using a single method. Together, they makes the banking system modular and flexible and easy to extend. Thank you for watching, guys. You are open to comment down any query. That is it for today.